Hi, and thanks for turning into my talk today about drinking water quality for Georgia livestock. My name is Martin Wunderly. I'm the area water agent for University of Georgia Extension in the Northeast District. Our project was funded by the Georgia Beef Commission, and on this first slide you can see the number of extension agents that collaborated in this effort. Raymond Fitzpatrick, Lucy Ray, Tammy Cheeley, Greg Pittman, Carol Knight, Thad Glenn, Stephen Patrick, Shanna Reynolds, Monty Stevens, Joel Burnshead, and Robin Stewart. So what we wanted to do was test some drinking water quality for livestock operations in Georgia. Livestock production relies on good water quality, and poor water quality can decrease animals' intake and cause health issues. And we note that Georgia livestock are drinking from a variety of sources: streams, ponds, well water, and trough systems that are not always maintained equally. You can see one of the pictures in here has a goldfish in their trough. I'm not sure if that helps or not. So what we wanted to do was, through this water testing effort, was just in general inspire farmers to consider the water quality that their animals are drinking. We wanted to do this across different counties for our water sampling effort, and these tests were provided free, and any further consultation was provided free to livestock producers in Georgia. Then we compared our water sources and different water quality results. All of the tests were conducted at the Agriculture and Environmental Services Lab in Athens, and we will advise farmers of different water quality protection measures to keep their animals safe, and it also ends up protecting the local water quality. There were 35 farms in 10 different counties in Northeast Georgia. 53 different livestock watering sources were sampled, from streams, ponds, and troughs that had water from bored wells and from drilled wells. 48 of these samples were from beef cattle operations, 2 were from dairies, 1 was from equine facility, and 2 were from goat farms. You can see the counties here with the star marking there. They had a participant in this project. These are the elements and characters that we tested for. And on the right side of the table, you can see recommended limits for livestock. These are from various sources dealing with veterinary recommendations, and some of them have probably been tested on animals, but some of them are from just a kind of estimate based on human consumption and human health limits. If the element has a capital P next to it, those also mostly have issues with palatability. They can affect intake just because they don't taste well. And the list includes pH, calcium, copper, iron, manganese, molybdenum, sodium, phosphorus, total dissolved solids, fluoride, nitrate, nitrogen, sulfate, nitrite, nitrogen, arsenic, cadmium, chromium, lead, selenium, conductivity, turbidity, fecal coliforms, and temperature. So what we found in our results for our water tests were that the most common physical contaminants that were above the recommended limit for livestock were iron in 32% of all the samples, manganese in 26%, and pH was either too high or too low in 13% of the samples. Now, 77% of the troughs that we sample with well water were within the safe limits for all of these physical contaminants. 25% of pond samples and only 18% of streams were within these recommended limits. High iron occurred more often in ponds and streams, and high manganese levels were similar across water sources. Iron and manganese can affect the taste or palatability and water intake. 4 troughs and 3 streams had unacceptable pH levels, and high or low pH can dissolve other elements either in the water supply infrastructure or in surrounding rocks in the aquifer that can be toxic or affect flavor. This can cause digestive upset, diarrhea, poor feed conversion, and reduce water and feed intake. We also sampled water temperatures. Above 80 degrees is warmer than recommended for livestock drinking. They'll actually reduce their consumption if water temperature is above 80. So it was only higher than 80, which this graph is just an example of 3 temperature probes that were in a pond, a trough, and a stream. And for these particular ones, you can see where they were, the pond was above 80 degrees for quite a while. Looks like a month or so there. The trough and stream were below that, but overall, from all the samples, only were above 80 degrees Fahrenheit 0% of the time for one stream, 16% for troughs, and 38% for ponds. And you can have a shading effect on ponds. So this particular pond in Madison County had a slightly lower temperature than the other ponds that we sampled, but it's covered in, I think that's duckweed. And then you can see the trees shading the edges of this pond, which are going to keep that temperature down. If you have a deeper water pond too, it's not going to heat up as much in the summertime. Now we had fecal coliform tests run on these water samples, and this is an indication that there's some animal waste contamination and other pathogens that can cause health issues. Fecal coliforms were higher than recommended in 85% of all the samples. So even water from troughs had issues with fecal coliforms, not just streams and ponds. And in fact, you can see in this table that ponds had the lowest average amount of fecal coliform and the lowest range of minimum and maximum in the samples. Corral troughs had the highest, between 5,000 and 9,000 most probable numbers per 100 mil. Some of these readings you'll find in the natural environment in some polluted streams or streams that aren't meeting their water quality requirements. But in these troughs, you can see some pretty high numbers, and also at a pretty wide range. And the corral troughs seem to have the highest numbers. But we also surveyed these farmers and asked how often they clean their troughs. And you can see on the graph on the lower right here, the fecal coliform count looks like it was definitely higher in troughs that only were cleaned once every year or once every 18 months. If you clean your trough more often, maybe twice a year, you can really cut down on the fecal coliform concentration. So basically from this project, we would suggest that troughs have the best water quality for physical contaminants, followed by ponds and streams. Streams had the best water temperature, followed by troughs, then ponds. The fecal coliform was the highest in corral settings, followed by pasture troughs that were out in the field, streams, and then ponds. But you may get the cleanest water if you use a drilled well for your trough, but just make sure to clean it a couple of times a year. There are some other methods that you can use we'll get into on the next slide. If you clean it at least twice a year, it's going to be more beneficial to cutting down your bacteria level in your water. And drinking water quality for livestock should be considered when providing access for your animals to ponds and streams, which in turn impacts local environmental water quality. This picture is from a dairy. Farms can get pretty creative in how they deliver water. There's automatic refill on this, but they're just using an old bathtub. Some suggestions that we came up with this project, that if you may need to add an alternative water source to increase your options for your livestock. Do you need to, are there chronic exposure issues with contamination, or you have runoff problems with fertilizer or animal waste from the pasture itself? Are there well water quality problems? One clean source or a pasture rotation with different water sources may be sufficient. It depends on the operation. And water treatment filters can take care of some of the physical contaminants, depending on the cost. If you clean your troughs more often, you can do that by draining them, washing them with a 5% bleach solution, or you can try this continuous chlorination here with a low concentration of 8 ounces of bleach per 1,000 gallons of water, which comes out to about 3 to 5 parts per million of chlorine. The animals can't really detect it. It's not going to cause any health problems for them, but it cuts down on the bacteria load in the water. Trough water temperatures can be reduced with shade structures or strategically placing them near tree lines. But what about water temperature in the ponds? And we went over that with that picture from Madison County. And you may want to think about fencing your livestock out and only providing, small paths cut across the vegetation buffers to a stream or a pond where they may be drinking the water. This will reduce fecal coliform and extra nutrients and cyanobacteria blooms in ponds and stream waters. It's possible that we could get some more samples this coming year, and we're going to definitely encourage water quality testing for farms, and maybe we can get some people to participate in some bleach treatments for their pasture troughs, and we can take some tests before and after that. And we'd like to survey some participants to see if they want to incorporate any changes or in their practice or water delivery, or try to change their water quality, and then see if they can't determine if there's any improvement in livestock production. And we're also going to create some programming through UGA Extension about livestock drinking water quality. We'll encourage water testing and provide some trough maintenance and pond and stream access education, and also provide some solutions to water quality issues for livestock drinking. So if you have any questions, I think I'll be at the Q&A for presentations. You should have been provided a link for that live Zoom session. And you can also email me here at martin.wunderly@uga.edu. So I hope you enjoyed this presentation and maybe hear from you soon.